Good morning, everyone. So today we will be discussing about how to analyze and design a truss. So let's begin. So first of all, as usual, you have to open your Staadpro, okay, by clicking Run as Administrator. Right click and select Run as Administrator. Do not simply double click it, it will not work properly. So after opening it, let us go to New Project. So this time we'll be using a truss. So let me give a file name which is like a truss, and in this case instead of space I will use this truss. Now in units you have to take meter and kilonewton, and remaining things are the same. One second. Now select next, then add pin, that is the same thing. So now we have got the usual screen which we get. Okay, just the difference is that we have selected truss instead of space. Now what you have to do is geometry, run structure wizard. So in run structure wizard, this time we will not use like the frame models and all those things. We will use truss models. So lots of models are available here. So let me take Hoy roof for the truss. You can use lattice truss, bread truss, Warren, wave breeze, north light truss, whatever is there in the database you can use. So today we will be seeing the Hoy roof. So they will ask you like, let us double click it, then you get this one. What is the length? Let me give the length as 50. Let me give the height as 10. Okay, and let me give the length as 60. So the number of bays will be along length will be 6, so each bay will be 10 meter. Height is 10 meter, and width, let me give 10. Let me give a 0 because let us do a 2D truss. Okay, so for 2D truss, width is 0, height is 10. Already I am given central height. This is the central height, and length is 60. Total length of the truss divided into 6 parts. So now I apply. So this is what we get. Length is divided into 6 parts. If you can see here, length is divided into 6 parts, and then the middle height is 10 meter. Okay, and width is 0, so that's why it is a 2D. Now let us transfer it to the main screen. So this is what we get. Let me cancel the grids by clicking here. Okay, and let us see it in clear like this. So this is the truss that I am telling you about. So central height, if I click here, they will say the length is 10, central height is 10. Okay, now each bay, these are the bays, 6 bays, 60-meter total length, so each bay will be 10 meter. You can see here each bay is 10-meter length. So that is done. Now after this, let us give the sections. Well, let us give the sections to the frame. Otherwise, it is simply a wire frame. There is no section provided in the frame. Let us give it. So here we have to go to the general. Then one second. You have to go to the general here. Then you have to define Now here you have to select steel because we are taking steel truss. Now here assign your profile. What type of steel you want to give? Angle section, double angle, beam, column, channel. Let me give angle section. Okay, so all the beams will be angle sections and made of steel. So add, close. So now steel, I'll select here, assign to selected beams, assign, done. Now let us give the supports. So here, so let us give a pin support at both ends. So I will create support, pin support, add. So this is the pin support. So let me select this node at first, then assign, assign. Then let me select this node at first, assign, assign, done. So it is now a truss having angle sections. Then it is a truss having two hinge supports at both ends. Okay, so this is done till now. Now let us go to the loads. Let and in truss we give loads only at the joints. Please remember, we don't give loads in between the beams. Truss is not made for loads in between the beams. Truss is made only for loading at the joints. Please remember that. Okay, a frame is different, a truss is different. In frame, the loads can be anywhere, but truss is made only for loads at the joints. So this is done. So now, yeah, if you try to generate the loads, so I'm saying loads and definitions, load case details, add, and load case 1, okay, add, close. So load case 1 I am selling. Now again you add nodal load. Nodal load. So let me give a vertical nodal load of suppose 10 kilonewton. Okay, nodal load 10 kilonewton vertical. So add, close. So this nodal load is 10 kilonewton. So at what nodes do you want to give the loads? We have not yet defined it. So for that, you select this one, then take the nodes cursor and select suppose these nodes. Okay, and you select this one, assign to selected nodes, assign. So I am giving 10 kilonewton load over these four members. Okay, so now that is done. Uh, Let me scale the load. You can scale it like this. You can select it and it gets scaled in this manner. Okay, so we have given the loads. Now after this loading is done, let us go to the there's no such thing is left right now. Let's go to the design part. Okay, so in design part you give current code as IS 800, limit state design. Now define the parameters. What type of parameters? We need to give the yield stress of steel. So yield stress is FYLD. So let me take it as 415 Newton per mm square. That means 415,000 kilonewton per meter square. Okay, so add. then close. Then let us go to the commands. Commands check code. We have to use this command once. Add, then take off. Okay, so you can see here what are the purpose of these commands. Okay, purpose of these commands. So check code you have to add. I have added. Now take off. I will add close. Okay, so here you can see, you can scroll below. This FYLD has a question mark. For that means yield stress of steel. I have not told the software like where I am applying this 415000. So now I'll select it. I select it in all the members of the truss. Then I assign it. Check code. Yes, we will do it according to the code for all the members. And you go to check code. Then assign to selected beams. Assign. Assign. Still take off. So we need to do it. Assign to selected beams. Assign. Assign. That is done. Now analysis. No print. Fine, it's fine. Add. Close. Then analyze. Run analysis. So they are saying that design will not be performed. There may be some errors going on. Let me see. Design is there. Okay, they may tell you due to like there may be some maybe some confusion. I don't know, but this pop-up comes out sometimes. Maybe it doesn't have to worry. So your work is done. So now let us see the members. Okay, suppose I am seeing this member. Double click on it. Still design. They are saying it as fail. Are you getting my point? They are saying that it is fail. Now let me check this. Still design. This is also failing. So in that 10 kilonewton load that I am applying, this is failing. Okay. Then let me, if I want to like see what are the designs that are given, sections, then I can also see it here. Click any of the member. Steel design. See here is 4046. You see beam number 11 section L 4046. So angle sections are in that manner only, isn't it? 4046, 100, 110, like 70, 78, like that. So it is 4046 angle section. Okay, so that is the specification of the angle section given. Okay, in the design. Now, but still it is failing. So let me see what are the members that have failed in total. So select by specification all failed beams. So most of the beams have failed when I give the load of 10 kilonewton. Now this beam has not failed. So if I click here, still design, it is passing. It has passed. But I want that the all the beams should pass. I want all the beams to pass, not just a few. So let me again go to the design. Okay, let me go to the general. When you come to the general, you see that there is one option given L4046. So that has been applied to all the members. That means like L4046, like similar like angle sections 100, 110, 20, 20, 10, like that. This angle section has been applied to all the beams. Now, since it is failing, so we need to give some alternative. Instead of this L4046 everywhere, we need to give a alternative section. So for that, Let me go to define. Not actually define. One second, close. Let me go to the design. Okay, so define commands. So here, once again, define parameters. Done. Select parameters. Commands. Yeah, in commands, when you go to commands, you select the select. Okay, so they will now give some random. If you select this one, now they will what they will do is they will do a new design. Okay, they will give some different dimensions to the angle sections, different beams. Okay, and then they will redesign it. So I'm selecting it, select, then take off, add, close. So now this select, I am applying it to all. Sign, yes. Still take off, sign, yes. Now I am doing the analysis once again. Add, close. Analysis, run analysis, save. Okay. Modeling. Now let me see how many sections have failed. Select by specification. So still now sections are failing, but this time lesser sections have failed. Okay, lesser sections have failed. Now again, let me do one another analysis. For here, let me go to general. See now, like slowly there are lots of options coming. Okay, so because like uh, since they are now giving alternate various random type of sections, so all the database generally gets generated. So let me give this one 80 80 18 to all the sections. Okay, then assign, assign, yes, I have assigned it everywhere. Now analysis, let me do the analysis at close, analyze, run analysis, save. Go to post processing mode, done. They will ask you for which load case, this one. Okay, modeling. If you select this beam, still design, fail. Okay, still there are many beams that are failing. So geometry, if I go to select here, select by specification all fail beams, still the beams are failing. Okay, so that means what, like you have to do some iterations. Okay, so general, again you go section, then like section database, you go to section database. So like you have to select from here, like angle section. So many sections are there. Let me take the highest possible, 90 40 80 80 18 is there. So 90 40 110, or let me take a uh, like so many sections are there. Okay, I'm just telling you, like this one 90 90 90 40 10. Let me give, add, close, and let me apply it to all. Assign to selected beams, assign, yes, yes. Then I'm doing the analysis, add, close, analyze, run analysis. Then go to post processing mode. They will ask you for which load case. Load case 1. One load only I am giving. So now select by specification, still failing. So that means what? The angle sections are not giving much fruitful results. So you have to now go for section database, and again you select some like channel sections. Okay, so many channel sections are available. Okay, and tube sections, pipe sections, solid rods, so many things are there. So you can select and you can do the iterations again and again until all of the members pass. So that is what I wanted to tell you. Like, I don't want to go too much of the iterations, okay? Because it will be a continuous process. At one point of time, you will arrive at the definite iteration. So this is like interesting, isn't it? You give various type of sections and you see how it is performing. Okay, and once you arrive at the final result, then your job is done. Okay, and suppose at this point your beam is, suppose at one point of time you have got the result where your truss is safe, then you just check what are the members given at each beams, what are the dimensions given at each beam. Just click on it and just see what is the dimension given here. Beam 9, it is this one, 90 40 10 is given. Then suppose here 90 40 10 is given, like that. Okay, 90 40 10 is given, remaining things are same. Okay, so that is all that you need to know for design and analysis of truss. Okay, if you have any doubt, you can let me know, and write the notes of this, whatever I have taught you by today. Okay, by 11:59 p.m. today, you upload it in Google Classroom. I will generate an assignment in the Google Classroom and you upload it. And after uploading, you will get the attendance for today. So, thank you very much.